Willkommen zu Impossible Prototyping. The tutorial for this video is about the CNC G-code controller. The plan is to go through each function and in the end explain the different settings. So we will first have a look at the different tabs. Each tab is connected with a different function. The first tab, called Simple Control, gives the possibility to just control the motion with just clicking on the movement you want to execute. First, we have to connect the printer, and therefore you can down here choose which port the printer is connected to the computer. There's also the possibility to use the simulation. This we will use in the tutorial video for now because I did not set up an CNC machine. And then you can choose the speed of communication and push to connect. And here we can see that when we just want to move along the x-axis for 10 millimeters, we just click on that. There's also the possibility to turn on and turn off the motors or run the start code. I will come later to that, how this is changed in the settings menu. Next, we have the advanced control, and this gives the possibilities to see what the move will do and to set, for example, to save some important positions, to also mill cycles or make some more complicated moves. This was very useful when I was using it to manually mill out some traces or front plates. I will not go too much into detail how it's working. I think it's nearly self-explained. So just try it out and you will understand how it works easily. The next function was really important for me because I'm using this program a lot for milling PCBs, and therefore the copper layer of the PCB is removed, and the copper layer just is only some micrometers thick. So I don't want to go too deep into the PCB when I'm milling away the copper layer. So it's really important that the system knows the exactly height on each position of the PCB. So therefore I can minimize the tip of the milling. To set the distance between the measurement points and the splitting of the movement, I will come to this later in the setting tab. The only thing you can set here is the region where you want your board to be measured, where the height should be measured, and this is also useful because when you have already a used PCB and it's just half of it is left, or you just want to use a smaller region, you can type in where you want to mill and it will just make the points there. I will start this, and in the simulation there will be random points, so it's every time it makes a measurement, this measurement will be random in the simulation, and I will pause the video till it's finished. So now it's nearly finished. What you will see is that it's probing the last point and it's probing the first point again, and then it takes the difference between these 2 points. And this is coming from that old Malian version didn't have an auto probe mode. So it was working over the end stop. And when the end stop is hit, the motor will be stopped immediately. And this can lead to losing some steps. And so what I'm doing is, if there will be some step lost, so the 2 measurements from the same point will have different values, I will then use the different and calculate it over all measured points so that the average is nearly the same. I don't know if it's useful for someone. In my case, it was every time like here, some part of a millimeter. After it's done, you can see the height map, and red regions will be higher and blue regions will be lower. And if you see that and you see, okay, there's too much variance, like there's 2 or 3 millimeter variance, you can go back and try to mount the PCB better and try to adjust that. But in theory, it's not necessary. It will be auto-compensated anyway. If this is done in the milling tab, you will have the possibility to set the auto leveling here. And if it's set, every height will be corrected to this value. In the next step, we have the art functionality, and there is the goal that you have a picture and you want to convert the picture into G-code. For that, I already prepared a picture. When I put this picture in like that, it will be a little bit strange because what I'm doing here is I'm mapping the brightness of a pixel to a specific height. Or in the laser mode, I will map the brightness of the pixel, I will map to the laser intensity. So our eye, it will not look so natural if you just make this conversion. So what is recommended to do is to use a program which is called Awesome Bump, for example. And in this program, you can load the picture, and when you load it, you can adjust a lot of parameters. And when you adjust these parameters, for example, it will change a little bit how the conversion is working. And the goal is to get out a contrast map. So this is more neutral for us to understand the picture. And if you use that instead of the original picture, it will look much better when you mill it or laser it in the end. So I already exported that file from Awesome Bump, and we can load the image now. And then we can transform the image, like we can rotate it. But in this, I think it's not necessary, but we have to rotate it, for example, 480 degrees. So that's the right way we want to process it, and we can also change the width of our area we want to engrave it. So I will just make it like 15, 5, and 15. So it's really small here. Okay, maybe this is a little bit too small. Give me a second. Make it just 35 and 35, and then you can adjust it that the dog is in the position you want to have it in the finish milling process. You can also make the corners round, for example, if you want, or even make it like a circle. And then when you hit generate, you get a lot of options, and there's actually it's to convert the picture. It's a complicated process, so you have to go through that. The names should be self-explaining. What I find extremely useful is that the sweep lines is true, because then you can use later in the milling tab, you can use the optimizations, and this will save a lot of milling time because it don't have to go over each line. When we're happy with the result, I will go through that. We're now in laser mode, so I will switch to the milling mode. And yeah, I actually don't check the settings, but we will just try to do it. And if it's done, it's imported here into the milling tab. And then we have a special layer which called it's called X, Epsilon and Z layer. Um, there we get the height map, and we see actually something went wrong because we can nearly not see the dock coming through. So you can go to the settings again. You can choose the distance between the lines. You can choose the maximum brightness, and therefore you can make more detail for the color, for black color, and you can also decide if black is milling or if black is not milling, and so on. So this is about the art function. Then now we're on the milling tab, and I will load now some CNC commands. Give me 1 second. So I loaded now a file which I used for milling the PCB of the word clock. What you can see here, every time I put down a text, that I can see if the orientation is right, so that you don't get it mirrored or something. And here are some functionalities now. We can go to the layer where the movements are happening. So when it's milling one part, it's then moving to the next part and it's milling that. And you see the export from my PCB G-code generator, which is available online for the Eagle PCB program. It's really messy. So what I have the possibility now is to press optimize, and during the optimize process, the path which is moved is tried to be minimized. And when I now look, it's much less. And I can load that again to see the difference again. So we see it's lot, and it's around 17 minutes to mill, and after optimization, it's still around 70 minutes. Okay, it depends on the moving speed and so on. Maybe it's not set it right, or it's just, yeah, that the milling takes so much longer than the moving, so it didn't do so much optimization here, so it didn't make so much sense in this case, but in other cases it can speed the process up a lot. When you scale it, it's possible to mirror it both ways. There also it's possible to scale it, so we can make it bigger. For example, in this case it makes no sense because the export should be already in millimeters, but doesn't matter, so we can scale it up like factor of 2. It's also possible to change the set height, so if the export, for example, has the wrong height for milling, you can change that anyway. And I also added a functionality for laser, so you can add here, for example, that every line gets a power reading for the laser. So, but this is an other entirely video itself, because I'm using an rotational X for my laser, and normally there's the parameter S is used, and I'm using the parameter A. So it's not compatible for the most setups, but maybe when I have time I will implement this anyway, that it's working with the S parameter. Yeah, and when we push milling, it's going through, and we can see now which line it's milling. And so you have a little bit of a preview what's going on, and you can compare it what your mill is doing. And we can also pause it and look at each line individually. We can resume it. If something went wrong, we can also make an abort. And if you don't lose the line, you can then later go here and start milling again from here. And what it's doing, it's running the start code again. And after that, it's moving to the last known point, and then it's repeating the milling from this point. We can also see on the other layers what's going on. And yeah, that's it for the milling tab, I think. You can turn off auto scroll, and then it's not changing here, and when you turn it on again, it's done. What else? Yes. The next step is about the communication. There's just like 100 lines of the last communication entries, what happened between the printer, the milling, the laser, and the computer. And if something went wrong, for example, you can see exactly what was going on. And you can also enter some commands here. For example, when I want to home my CNCX manually, then I can just enter it here and it's executing the command. So you can, for example, for GRBL, you can enter your settings commands here and it will work. And now to the last tab, the setting tab. One important setting is the homing. And for the homing, there is like 4 different options. I think lower left is the standard option, and when you make your machine correct, this should be the setting you choose here. But if, for example, the X or the epsilon axis is mirrored, this can be corrected here. So if you do that, for example, and we go back to the milling tab, then we should see that now this stuff should be mirrored. Okay, I set it now to the upper left. Yeah, and now we see, okay, our screen is completely mirrored. So when you make the setting the first time, be sure that this is matching your machine. And this is really good when it's matching, because you can see immediately if something is going wrong with mirroring or so, because the result, what you're seeing here, is exactly what your machine will do later. So this is the first stuff you should figure out, which setting is right for your machine. Then this is for time calculation. You can type in here how fast is your machine and how big is the size of your machine. And what I'm seeing actually here, I have loaded the settings for my laser. So this is also the reason why the optimization before didn't make so much difference. But you have the possibility when you're using 2 machines, you can export and import settings. So when I go here and import my CNC settings for my mill, yes, I need this for milling my PCBs, and this is now imported. Then you see I have other start codes, I have another size and so on. And when I now go back, it looks a little bit other because my milling machine don't have so much working area as my laser cutter. And when I now look, it's 21 minutes. And if I load the file again, here it is. It's 30 minutes. So the optimization actually saved us a lot of time. So if we're doing it now again, the optimization, it's saving us 9 minutes. So it's I think it's around 30% of the whole time. Correct me if I'm wrong. So this is also important. So you have the size of your working space. The next stuff is you have to have some kind of homing, and for my CNC mill it's actually a little bit more complicated because I have a reference switch, and every tool what I'm using is going first to this reference switch so that the height of the tool is every time the same. So this code is actually doing that. It's going to the position where the reference switch is, and then it's making a probe there, and then it's going back to the homing position. And I also have the possibility to make tool changes. So this is what I didn't talk about. When I load, for example, the drill file, I have here now the drills, and when we look here, there's actually a tool chain with the M06 G-code, and during this tool chain, it's actually using the code of the tool chain. So what I'm doing here is I'm going to a fixed position, and then I do just the wrong sequence for my GRBL interpreter, and it's getting me an error message. So during this error message, everything is stopped, so I can change my drill bit. And then if it's changed, I just tell, okay, this happened and don't care about it. So I say, okay, continue. And then it's running the homing for this milling bit again. So it's referenced to the 0 position. And then the script is making the drill holes. What is also interesting is that some machines don't, for example, some commands are converted. I don't know if in this actual implementation there is the drilling function for the G-code is implemented to be converted, but for the inner structure of the program, it should not be so hard to add new functionality to the G-code interpreter I'm using internally. Okay. When you have GPL or you have Marlin or so on, the commands to turn on and off the motor for the drilling machine, for example, can be really different. So I have the possibility to set this here, and okay, what happened? Yeah, I don't know. The screen capturing is causing a little bit of buggy situation here. Then I have to set the feed rate for G0. What is this about is, for example, Marlin don't understand the difference between G0 and G1, so I convert every G0 internally to G1, and this is the speed what is used for G0X, for example. This is for the laser stuff internally. Here I can set the tool width, and this is just used for displaying the tool path. This is the time which the optimization algorithm is running. It's trying to optimize as much as possible, and this can take up hours. And so I set a maximum time that it stops after some time. It's just trying to optimize the biggest, and then after some time, the optimization actually don't make so much difference anymore. So it's good that you have a timeout, so they don't have to wait too long for something which is actually not have any effect anymore. This option here are a little bit more important, and we have to talk about. And this is the settings about the auto leveling process. And you have to go through that and see what's working for your setting. These are my settings I'm using, and this, for example, is a little bit of problem because the first probe is taking a long time because it has to go from the safe height to the board. But I'm trying to be a little bit more careful than to be more fast. So I don't care about this actually. And this is also important when you do the auto leveling, and for example, one milling move is really long. Then these settings will actually cause the moves to be splitted into separate moves, and each move get height corrected. So when you have a high resolution and you make a lot of probing, then you should also decrease this distance so that actually long moves get also really high precision. This is the start code for auto leveling. For me, it's exactly the same as for this normal start of a program, but this can be different depending on the machine. For example, you can, when you have Marlin, you can use a servo which is automatically making the probe pin accessible, for example. So this can be written here. Then also this software is converting the circular moves from the G-code to linear moves, and here you can set which segment lengths each circular move will be converted to. So this will increase the precision, but it will also increase the amount of G-codes you have to send. There's also a possibility for backlash correction, so this is implemented. And yeah, you can set the colors, and this is also really important. You can set here what kind of machine you're using. So if you're using the GPL firmware, you can choose that. If you're using the Marlin firmware, you can choose that. And generic is for testing, and maybe some machines also support that. And maybe if you have some ideas what other types of firmware should be supported, I can try to support that. I have to tell that the Marlin support is a little bit old because I'm actually not running a Marlin machine right now. So if someone have a Marlin machine at home and some knowledge about how to program, so maybe it would be really nice to test everything and give me some feedback, and so we can make this whole stuff working better. Okay, that's it.